Alright, here we're going to be talking about compound probability. So last year you learned about simple probability, which we're going to go over a little bit, which is just dealing with one event. Compound probability is going to be dealing with more than one event. So probability in general is just the likelihood that an event occurs. And it's always written as a simplified ratio. So you can write it as a decimal, you can write it as a percent, or you can write it as a fraction, but if you're going to write it as a fraction, it should be simplified. The probability of an event is always between 0 and 1. 0 represents that it is completely impossible. 1 represents that it's absolutely certain it will happen. And 0.5 represents that it's equally likely that it doesn't happen and it does happen. So a coin flip has a 1/2 chance or a 50% chance of happening, or 0.5 as a decimal. The way we come up with a probability, the probability of an event, is the number of favorable outcomes divided by the number of possible outcomes. So when I say favorable, I don't necessarily mean that it has to be good, it's just really what we're talking about. So if I talk about a coin flip, a favorable outcome could be the chance that it lands on heads. Heads would be the favorable outcome, heads and tails would be the total possible outcomes. There would be two total possible outcomes, where heads, the one outcome that I'm looking for, is the favorable outcome. So that would be a 1 out of 2 chance. Alright, so looking at this spinner, whoops. We have a spinner with 8 sections on it. The number of possible outcomes is 8. It can land on any of those sections, and it's equally likely that it lands on any of them. We want to know what is the probability of spinning an odd number. So first, let's just identify the odd numbers. 1, 3, 5, 7. So we have 4 odd numbers. Those are my favorable outcomes. That's the possible things that I'm looking for there. Out of 8, which is all the possible outcomes. If I'm going to write it as a fraction, I have to simplify that. So you could divide the top by 2. Sorry, you could divide the top and the bottom by 2 if you wanted to. But you can divide by a bigger number. When you're simplifying fractions, it's just easiest to divide by the biggest number possible. You could divide by 2 because they're both even, but we can also divide by 4. I know that 4 goes into both of those evenly. That's really what I'm looking for. I'm thinking about what will divide the top evenly and the bottom evenly at the same time. It's got to be the same number. So I divide straight across. 4 divided by 4 is 1. 8 divided by 4 is 2. So the chance that I get an odd number is 1/2, which makes sense. Half the numbers are odd. This is a different way to write that same kind of thing. Instead of writing out the full sentence, this is saying the probability of whatever is inside the parentheses. The probability of getting an even or a 7. So that means all of those are my favorable outcomes. I can get an even, which means 2, 4, 6, or 8, or I can get a 7. That is 5 out of my 8 possible outcomes. And that one doesn't simplify. That is the final answer there. Alright, on the second one, a bag contains 5 blue, 8 red, 7 green marbles, and a marble is selected at random. So we reach in, we pick out a marble. We can get any of these 20 marbles. 5 plus 8 plus 7 is 20. So there's 20 possible outcomes. I can get any one of those 20 marbles. The probability that I get a green is the number of green out of the total number of marbles. 7 out of 20. And that one doesn't simplify. The probability that I get a yellow, well, there are no yellow marbles, so that is 0. 0 out of 20, or really just 0. There is just no chance that I get a yellow one because there are no yellow marbles at all. What's the probability that I get something that's not red? So that includes anything that's either blue or green. So that's 5 plus 7. There's 12 options that are not red there. So that's 12 out of our total of 20. And then I recognize that those are both even numbers, so I definitely need to divide by at least 2. But I also recognize I could divide the top and the bottom by 4. If you don't recognize that, that's okay. You can just divide by 2 and then divide by 2 again. But I see that 12 is divisible by 4. 20 is divisible by 4. So that would give me a final answer of 3 over 5. You divide the top by one number, the bottom by that same number, and that simplifies the fraction. All right, so that was all simple probability. That should really just be a review of what you did last year, where we just have one thing happening, picking out a green, picking out a yellow, picking out something that's not red. One thing's happening. Now we're talking about more than one event. Two events are called compound events, and they're either going to be dependent or independent. So we have independent events and dependent events. The outcome of one event will not influence the outcome of the next event for an independent event. So it does not affect the outcome of the next event. So when I say that, really there's two different scenarios we could be thinking about, where the events are completely unrelated. If I roll a die and I spin a spinner, the die and the spinner have nothing to do with each other. They don't affect each other. Those are unrelated. One event does not affect the other event. The second is when you see this phrase, with replacement. So if we talk about a bag of marbles, I take out a marble and I replace it. If I put that marble back in, the first marble that I picked out does not affect the probability of the second marble that I picked out, because I replace it and I reset the bag. That is different from when I do it without replacement, with a dependent event, where the outcome of one event actually does affect or influence the outcome of the next one. So the same example, I have a bag of marbles, I take out a marble and I keep it out. If I don't replace it, if I do it without replacement, that means the bag is different from how it started. The first event actually changed the second event. We're going to do some examples with that. So if that went over your head, that's okay. Determine which of these sets of events would be either independent or dependent. So we're thinking, are they related? Does the first one actually affect the second one or not? So rolling a number cube or a die and flipping a coin, those have nothing to do with each other. Those are independent of each other. They do not affect each other at all. Picking a marble from a bag, giving it to your friend, and then picking out a second marble. This step here, once I give it to my friend, it's not in the bag anymore. The bag has changed. I took a marble out, didn't put it back in. This new bag has one less marble. Those are dependent events because taking that first one out somehow changes the bag. The second event, the probability has changed. Picking out a Jolly Rancher from a bag, eating it, that Jolly Rancher is now gone, and then picking out another Jolly Rancher, well, the bag has changed. I picked out a Jolly Rancher here, I ate it, now this is a completely new bag with one less Jolly Rancher. Those are dependent events. The first event affects the second one. The last one, picking out a Jolly Rancher from a bag, putting it back in because you don't want that flavor, and then picking out another one. When you put that one back in, you've changed the bag, you've reset the bag, and the first Jolly Rancher actually doesn't affect anything about that second Jolly Rancher. We've reset the bag. It's the same bag as it was before, so the first event does not influence the next event. Okay, so you do need to decide that, whether they're independent or dependent, because it's going to change the probability. And the way we actually find the probability itself, the number for the probability, is by multiplying the two probabilities together of the two different events. So first off, you have to decide whether they're independent or dependent, because that's going to change the probability. But really, it's simple. Find the probability of each event, and then multiply. So it's just like simple probability, except now we're going to have two, and we're going to multiply them together. So example 1, Miss Goitia loves movies and can't decide which 2 movies to watch tonight. She puts 4 fantasy DVDs, 3 drama DVDs, and 5 comedy DVDs in a bag. This is kind of an old question because DVDs don't seem to really be a thing anymore. What's the probability that Miss Goitia will pick a drama, replace it, and then pick a comedy? Okay, so first off, she's putting that first one back in. She doesn't want the drama. She's putting that back in and then picking comedy. She's reset the bag that she's putting these DVDs in. These are independent events. They don't affect each other. So we're going to find the probability of each event. When I say that, I mean, what's the chance that we get a drama? And then what's the chance that we get a comedy? So the probability that we get a drama, well, there's 3 dramas. Out of, I'm going to add these together, 4, 3, and 5 put together is 12. Then the probability that she gets a comedy, well, there's 5 comedies. There's still 12 DVDs in the bag. We replaced that first one, so it's still at 12. And now we're going to multiply them together. Before multiplying, I'm going to simplify. You can simplify at the end, but it's easier for me to deal with smaller numbers. So I'm going to simplify this one first. Divide by 3 on top and bottom. That changes into 1 over 4. and then I can multiply 5 over 12 times that. You can simplify at the end if you want. I think it's easier to simplify in the beginning. You multiply straight across. When we multiply fractions, this is not like what we just did with proportions. That's cross multiplying, where this would be an equal sign in between. Here we're just multiplying fractions, so we multiply straight across. 1 times 5 is 5. 4 times 12 is 48. So the chance that she gets a drama, puts it back in, and then gets a comedy is 5 out of 48. Example 2. Miss Kamiyama wants to pick a few pieces of candy out of a jar. There are various pieces. 5 strawberry, 4 orange, 3 grape, 3 watermelon. What's the probability that Miss Kamiyama is picking out a strawberry piece? She gets a strawberry, she eats it, and then she chooses a grape. So that step in the middle is really important. Once we eat that strawberry, there's one less in there. So to start out, we have 5, 4, 3, 3. That's a total of 15. There are 15 pieces of candy here. Once we eat that one, there's now only 14 pieces of candy. That's what I mean when I say these are dependent events. The first one actually affects the second one. The probability has changed because we ate one of those pieces of candy. So these are dependent events. The chance that we pick out a strawberry is 5 out of 15. We ate that strawberry, and now we want to think about the chance that we get a grape. Well, there's still 3 grape in there, but not 15 total anymore. Now we're down to 14. Again, I'm going to simplify a little bit before I multiply. I know I can divide that by 5 and that by 5. So that changes into 1/3 times 3 over 14. And then I'm going to multiply straight across. 1 times 3, 3 times 14, that's 42 on the bottom, and 3 on top. And it might not be that easy to recognize this, but you can divide each of those by 3. You can kind of see it here. We multiplied by 3 there, so we know we can divide this by 3. Definitely can divide 3 by 3 and get 1 over 14 as our final probability. And example 3, one letter is selected from the pile, so we're going to pick out one letter from here and spin the spinner. What's the probability that both letters selected are not vowels, not A, E, I, O, or U? I'm going to plot that on the number line. All right, so not A, E, I, O, or U. So the chance that we get something that's not a vowel there is 1, 2, 3, 4, 5 out of the total of 7. On the spinner, same thing, not A or E, but we can get any of the other ones. That's 1, 2, 3, 4 out of 6. So the chance that we get not a vowel on the first one is 5 out of 7. The chance that we get something that's not a vowel on the second one is 4 out of 6. Now we can multiply those together. I'm actually going to simplify this a little bit first. 6 and 4 are both even numbers, so they divide by 2. So we get 2 over 3 as an equivalent fraction to this 4 out of 6. So I'm going to do 5 out of 7 times 2 out of 3. Again, you can simplify at the end. Or actually on this one, since we're dealing with a number line, you could just change it into a decimal. Either way, we're going to get 10 out of 21. If you want to change that into a decimal, you can. But since we're kind of just estimating where it is on this number line, I know that's a little bit less than half. 10 out of 20 would be exactly half. This going up by a little bit means that's a little bit smaller. So 10 out of 20 would be just a little bit smaller than 1/2. Got all distorted. I'm going to rewrite that again. But 10 out of 20 is just going to be to the left of 1/2 on the number line. Last example. 2 students are selecting marbles from that jar. Determine the scenario. Which scenario is more likely? So we want to know which is more likely to happen between these 2 scenarios. Isabella is going to pick out a blue marble. She's going to keep it and then pick out a yellow one. All right, so we want to think about what's the chance that we get a blue. Well, there's 1, 2, 3, 4 out of 1, 2, 3, 4, 5, 6, 7, 8 out of 12. 4 out of 12 is the chance that we get a blue. She keeps it. So she's taking one of these marbles out. You imagine this one disappearing. Doesn't really matter which one. But now we're down to just 11 marbles. So the chance that we get a yellow is 3 out of 11. So I'm going to simplify this first one by 4. That's going to change into 1/3. And then I can multiply that times 3 over 11. This is kind of similar to the one before. You recognize that we're multiplying by 3 here. So when you multiply straight across, 1 times 3 gives us 3. 3 times 11 gives us 33. We can also simplify this a little bit by dividing by 3 on top and bottom to find out that that is 1/11. So the chance that she pulls out a blue one, keeps it, and then pulls out a yellow one is 1 out of 11. What's the chance that Ian pulls out a yellow one, puts it back in, and then gets another yellow one? So yellow followed by another yellow. Well, the chance that he gets a yellow one is 3 out of 12. There's 1, 2, 3 yellow ones out of 12. We've reset the jar of marbles in between these two questions, so we're back to 12 as our total. And we're still going to be at 12 for this second yellow marble. When you put it back in, you're resetting the jar, so it's still 3 out of 12. We can divide the top and the bottom by 3 on both of those, and get that this is really just 1/4 times 1/4, which is 1/16 altogether. So we're thinking about which student had the greater probability. Well, this is a little bit bigger. 1 over 11 is bigger than 1 out of 16. So Isabella has the better chance of doing what she wants with getting a blue and a yellow than Ian did with the 2 yellows. All right, hope this helps.